Trigonometric identities, Pythagorean identities. That is the first set of Pythagorean identities. Then we have the Pythagorean identities with the reciprocal trigonometric ratios. Okay. Now it is most important for you to understand these four set of basic trigonometric identities to prove any trigonometric identity. Okay. So I like you to understand their proof, and that will also expose you to the way we should move forward in doing this chapter on trigonometric identities. Okay. Now here is the very first Pythagorean identity, sine square theta plus cos square theta equals to 1, and this is the most useful of all. Always 75% of the time you will be using this identity in many different ways. Okay. So let's go through the proof of this. Okay. So we will just consider one right triangle and then show you how from there we can prove this identity so easily. Okay, so that's my right triangle, and in this, let's call this side as the opposite side, that as adjacent A, and hypotenuse H, and this is my angle theta. So that's all what I need in this right triangle. Okay, now from the rule of SOHCAHTOA, you know, sine is what? So let me write those things also here for you. That helps. So you have sine theta is opposite over hypotenuse, right? Let me write O over H, right? And cos theta is adjacent over hypotenuse. It is A over H. Okay, that helps, right? So this is what we are looking for, a relation between sine theta and cos theta, right? We already know the Pythagorean relation, right? Which is the side squares. Sum of side squares is equal to the square of the hypotenuse. So we'll use the Pythagorean theorem to prove our identity. So the Pythagorean theorem is that we have O square plus A square equals to H square, right? So this side square, which is the opposite side square, plus the adjacent side square is equal to the hypotenuse square. Is that okay? So that is the Pythagorean theorem, right? Now, what happens if I really divide this by hypotenuse square? So let's do that. So we know this is Pythagorean theorem. We are just dividing both sides by hypotenuse square. Well, you can always do that. Only thing is, it should not be 0. You can divide by any number on both sides of equality, correct? You get the same equivalent equation, correct? What is identities? Identities are equations which are true for all values. That is what identities are. Equations may not be true for all the values. Equations may be true for only few values, correct? But the identities which we are proving, they are true for all values in their domain, correct? That's how it is. Now, if I divide by hypotenuse square in all the three terms, what do I get? I get O over H whole square plus A over H whole square equals to H over H is 1. I get this equals to 1. Now, what is O over H? What is O over H? O over H is sine theta. Oh God. So we get sine square theta. Do you see that? So we get sine square theta plus A over H is cos theta. A over H. So it's cos square theta equals to 1. And that is so simple to prove. So it is such a basic identity, but so useful. Beautiful it is. Sine square theta plus cos square theta is 1. Just remember, sine square theta plus cos square theta equals to 1. Perfect. Now, these are the two ways of writing the same thing. So what we can do is, we can rearrange it. So let me just rearrange and write it on this side. So when I rearrange it, I can write sine square theta is, I'm taking cos square theta on one side. So I write sine square theta equals to 1 minus cos square theta. Oh, that's what I had written there. Perfect, perfect. This is how it is. And how about cos square theta? To find what cos square theta is, you'll take sine square theta to the right side. So cos square theta is 1 minus sine square theta. So we can rearrange this formula and use it in so many different ways. you will see most of the questions involving this, right? And I'll add few more things here since we're talking about such an important function. You know, difference of squares, that is okay, how should I write? So let me write it like this. What is a square minus b square equals to? A square minus b square is a plus b times a minus b. Perfect. So we have 1 minus sine square theta. So I can write this as 1 plus sine theta times 1 minus sine theta. Do you see the beauty? So I can write like this. So cos square theta is also equal to 1 plus sine theta times 1 minus sine theta. Similarly here, I can write sine square theta is also equals to 1 plus cos theta times 1 minus sine, 1 minus cos theta, okay? So kind of spoiled it. I get 1 minus cos theta, okay? So it's product of 1 plus cos theta and 1 minus cos theta also, right? So you can add this to your list of trigonometric identities which are very, very helpful to prove identities, okay? I hope you will love this. Share it with your friends and write comments if you really like it. Thank you.